Alright, what is up from 5? I hope you are doing well. Welcome back to our weekly class. This week, we are entering hydraulic system. Okay, I hope you still remember what we studied last week. We studied pressure. Okay, so this week, we apply pressure into liquid. Okay, last week is all solid. Okay, like you remember your knife, your nails, your tires, your snowshoe, they are all solid. Okay, this week, what happens when we apply pressure to liquid? Okay, so think of it this way. Liquid cannot be compressed. Okay, liquid, you cannot compress. Okay, so when you press liquid, the force has to go somewhere. This is what we meant by hydraulic. Okay, so let's say now you have a system like this. This is a simple hydraulic system. Let's say I press on A, piston A, all the force will go to piston B because liquid cannot compress. Okay, this is basically how hydraulic works. Okay, this is how your brake works. When you step on a pedal, you step on A, and then B is pressing onto your wheels so that your wheels will stop. Similarly to your brakes when you're using bicycle. So you press here and then you are pressing on the wheels. Okay, so this is what I meant by hydraulic. Basically, it's a liquid pressure system. Okay, so a piston is pushed. Okay, can you see if there are holes here? All this will be pushed out. Okay, like your syringe. Okay, you know your syringe. Okay, same thing is hydraulic also. Okay, so when pressure is applied onto a liquid, okay, pressure will be transferred to all parts of liquid uniformly. Okay, this is what's the beauty of hydraulic. Okay, it will be transmitted equally throughout the whole system. Okay, the whole system would have equal pressure. Okay, which means this whole thing, the one I draw just now, everywhere would have, you stand anywhere, would have the same pressure. That's the beauty of hydraulic. Okay, so this is what we call hydraulic principle or Pascal principle. Why Pascal? Remember our pressure unit last week? Okay, we did some calculation. It was called Pascal because he discovered it, so we name it Pascal, like Newton or like Watt. Okay, same thing. Okay, so the hydraulic system, the force produced on a big piston is multiplied compared to the force on a small piston. Okay, what is meant by this? Okay, let's look at this thing. Okay, whatever pressure is here, here would have the same pressure. Like I said just now, throughout the whole system, pressure is equal. It doesn't change. You stand here, 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 here. Anywhere, pressure is the same. That's why we come to this equation. Pressure at point A, at point 1, is the same as pressure at point 2. So basically, this is Pascal formula. P1 equals to P2. And then last week, we learned that pressure is force divided by area. Okay, so we change this. F1A1 is equal to F2A2. Okay, basically it's just changing P equals to FA. Okay, so you might ask, so what? Okay, that's the thing, that's the beauty about this. Okay, you see, let's say now I apply 10 Newton here. This area here is 2 cm, which is very small. Okay, so my pressure here is 10 divided by 2. Okay, because force divided by area, I would get 5. Okay, I would get 5. Okay, so like I said, pressure is transmitted equally to here. So this part here, I get 5 Pascal. Here, I would also get 5 Pascal. Okay, but look at here. The area here is 100. So from this, what am I writing here? Okay, anyway, this is 5 Pascal here. 5 Pascal. So I know P equals to FA. So 5 equals to pressure divided by area. So what's my area? My area is 100. So 5 times 100, my force here, okay, I wrote this wrongly. My force here is 500 Newton. I can use a 5 Newton force, 10 Newton force, which is like 1 kilo, because they're by 10 ma. I use a 1 kilo force, I can lift 50 kilo, you know. Okay, I'm doing 50 times the force. Okay, which means I can use this, a small force, to generate a very huge force. This is what's the beauty of hydraulic. This is how your brake works. Okay, do you know how much force you're generating per wheel when you're braking at 100 km per hour? You're generating hundreds of newtons of force. Can you do that with your bare hands? No, you will die. But you just simply have to press on the brake. That's like what, 1 kilo, 2 kilos of force. You're generating 500-600 kilos of force per wheel. So this is the beauty of hydraulic. Can you see how, why? Okay, so this is basically how we generate a huge force using a small force. Okay, this is similar to a hydraulic jack. You know what's a jack? When your father sends the car to repair, the mechanic has to jack the car up using a floor jack, okay, to lift your car up. That's how it works. Your hand just have to pump a few times, like few kilo force. They can lift your car up. Your car is 1000 something kg. So can you see? It's like 20, 30 times, no, maybe 100, 200 times of pressure or force there. Okay, so as the application here, as the formula says here, the lower the area, the lower the force I'm using. Okay, high area, high force. Okay, so if you look at the piston, if you look at the jack, the one we are pressing onto, the piston is very small. Okay, like the brake we press onto, the piston is very small. But when you go to the part where you lift the car up, the piston is super big. Same goes to your brake. Your brake has one piston. If you're driving a race car, it's two piston, three piston each brake. Okay, so this is basically how pressure works. Okay, so hydraulic, okay, a very beautiful thing. If you want to generate a very large force with a very small force, you want to multiply your force, you use hydraulic. Okay, this is the one of the best machine known to mankind. Okay, so let's look at the example. An hydraulic system have two piston. This is basically what we did lah. Okay, 2 cm and 100 cm each. Okay, so I know F1A1 equals to F2A2. So make sure you label them. So this is a small, let's say this is A1, this is A2. I like to label my numbers lah so that I don't get confused. Okay, what is the weight of the load can be raised by the system? So basically they want F2. They don't know what is F2. If my F1 is 10. So basically 10 over 2 equals to F2 over 100. Okay, so my F2 I should get 500 Newton. Okay, same like just now. Okay, I'm raising a 50 kilo force using 1 kilo force. Okay, simple concept. Okay, nothing much here. Okay, so let's look at water. Okay, today I want to talk about someone named Archimedes. Okay, Archimedes. I'm sure you have heard of him. Okay, so before that, let's look at ships. Okay, they are streamline shape. You know a streamline? Basically, it's like a bullet. Okay, your bullet is streamlined. So when your bullet is flying through the air, okay, so it cuts through the air very smoothly. Okay, this is what I mean by streamline. Okay, ship is like that. That's why the front part is sharp, like fish lah. Okay, takkan you have never seen a fish that has a square shaped head. That would be a very stupid fish. Okay, it's a lot of resistance there. Okay, so can reduce friction of water resistance. Okay, streamline shape are basic in designing vehicles in water. Basically all vehicles now is streamlined. Okay, you see our car is getting rounder and rounder. If you look at the 70s, cars are very boxy. Okay, it's like square. Okay, and then scientists found out that they are not so streamlined, they are wasting a lot of petrol, so they change them into rounder shape. Okay, if you look at all the Hondas and Toyotas, they are all very round shape. Okay, so this is to cut through air smoothly so that it reduces your petrol. Okay, so Archimedes principle. So Archimedes principle is basically to deal with buoyancy. Okay, buoyancy. Okay, a little bit of story about Archimedes. How he found out about buoyancy is I'm sure you have heard of this story before. Okay, the king has a crown made. Okay, he made a new crown, but he don't know whether the crown is made of real gold. So he asked Archimedes. Archimedes didn't know as well. So he went home and he took a bath. So he sat into a bathtub, and then the water leaks out, and then he shouted Eureka. Okay, what is meant by Eureka? Okay, basically it's Greek, which means I got it. Okay, voila. Okay, it's like a light bulb lights up in his head, and then he found out that he can use water. He can use the real crown and the newly made crown and then put it in water. If the water that came out is the same, that means it's real gold. If it's not, then it's fake gold. Okay, so basically it's buoyancy lah. Okay, so you might say, so why do I care? Okay, Mind you, Archimedes was alive 4,000 years ago. Till today, 4,000 years later, we are still using his concept. Same like your Pythagoras theorem. C square equals to A square plus B square. Okay? So can you imagine you saying something 4,000 years later, people are like, you know what, this guy is pretty smart. We are still using his concept. That would be a very cool thing. Okay? Even 5 years back, the things you said, you would be like, oh my god, what a stupid thing I say. Okay? But 4,000 years later, we are still using these guys' concept, okay, invention. Okay? That's pretty wild. Okay, so when you submerge anything inside water, okay, let's say now you were to jump into water now, you feel very light. Okay, so now when you jump into water, you feel light. Okay, why? Because the water is pressing a force onto you. The force, we call it buoyant force. Okay, buoyant force. Basically, it's what makes you float lah. Okay, buoyant force, or we call it upthrust. Okay, it makes you float. It makes you float. Okay, so Archimedes' principle states that the weight loss of an object is equal to upthrust x on the object. Okay, which means, let's say now I'm 50 kilo, I jump into water, I jump into water, I'm 30 kilo. Okay, I feel like I'm 30 kilo. So what's my upthrust? My upthrust is 20. Because I lost 20 ma. Okay, this is the one I lost. Okay, I lost 20, so the upthrust is 20. Makes sense, doesn't it? Okay, let's say this is you. You are going down with 50, but the water push you back 20, you get back 30. Okay, you earn 50, you spend 20, you get 30 back. Okay, makes sense. All right, so upthrust is equal to weight loss, okay, or the weight of liquid displaced. How much liquid you push away. Okay, liquid is a very funny thing. How much force you press onto it, how much force it will press you back. Okay, like when I let's say now I displace away 20 cm cube of water, water will push you back with 20 Newton. Okay, this is a given. Okay, so here's the thing. I'll talk about this later. Okay, so let's look at this experiment. So let's look at this stone, this pebble. Okay, in air is 7 Newton. That's the real weight. Okay, but when I put it into this thing is called Eureka can, because Archimedes shouted Eureka, so we named this thing Eureka can. Okay, pretty smart if you ask me. Okay, so when I put it into water, it's only 5 Newton. So it lost 2 Newton. Okay, so the upthrust is 2 Newton, and then how do we verify this? The water being pushed out is 2 Newton. So smart, isn't it? Okay, I push out 2 Newton, so I push into water, I push away 2 Newton of water, so water will push me back 2 Newton. Okay, so 7 minus 2 is 5 lah, so I only get 5, so I feel lighter. Okay, but this thing still sinks. Okay, here's the thing. Okay, can you see? In air is 7, in water is 5, so 7 minus 5 is 2, so the upthrust is 2. Okay, upthrust, or the weight of water displaced lah. Okay, so here's the thing. This is the stone. It's 7 going down. It's 2 going up. I'm still 5 going down. I'm still sinking. This stone is still sinking. Okay, here's the question I want to ask you. The stone is 7 Newton, it sinks. But a ship, okay, a container ship is 5,000 tons. It still floats. Why? Okay, why? This is what I want to talk about, which is buoyancy. Okay, as long as your upthrust is equal to your weight, you will float. Okay, can you see? Just now my weight is 7, my upthrust is 2. My weight is heavier than my upthrust, I sink. If my ship is 5,000 tons and the upthrust is 5,000 tons, I'm still gonna float. Okay, so at the end of the day, it's all about how much water I pushed away. Because the more water I push away, the more upthrust I get. Remember, I push away 20 Newton of water, water will push me back 20. So all I have to do here is to push away 5,000 tons of water. So 5,000 tons of water will push me back. So how do I do that? Of course, I make the base area as wide as possible. That's why you see ship down there is very wide. I want to push away as much water as I can, so the water will push on me as much as they can, so that I can float. Okay, I hope this makes sense. Okay, so if my upthrust equals to my weight, imagine this is a lift lah. Okay, you're standing in a lift. If your weight is the same as the lift pulling on you, you're going to stay there. Make sense? Make sense? You're standing on the lift, the string is pulling onto you. Okay, you are 70 kilo, the string pulls you 70 kilo. So you are going to stay there, you're not going to move anywhere. Same goes to buoyancy. Okay, basically this is the concept. Okay, so for ships, they will have something called a plimsoll line. Not sure whether it's here or it's not here. Okay, plimsoll line is basically the line that tells you what your ship is supposed to sink. Okay, let's say you're the captain of the ship. You have to follow this line. Okay, why? Because different water has different density. You might be in salt water, you might be in very salty water, which is very dense. Your ship will float higher. Okay, so can you see this is the plimsoll line? Okay, so they will tell you there, can you see fresh water, okay, tropical salt water or whatever. You have to follow this limit. If not, okay, here's the thing when overloading a ship. When you overload a ship won't sink. But when the ship bounces back up, your ship will go like this. It will flip upside down. I'm sure you've played with toy ships before. When you press the ship into the water, and when the ship comes out, the ship will just flip. Okay, then everybody will die inside. Okay, that is what we don't want. That's why you don't overload a ship. Okay, people can die. Okay, so basically this is the same for submarine. So if I want to float, I throw water out with my, this is the ballast tank surrounding it. I throw water out. Okay, so now I will float. Okay, because I'm reducing my weight. If I want to sink, I will pump water inside. Okay, and then I will sink. Okay, basic simple concept. All right, so today we are learning two things. We are learning hydraulic, okay, and we are learning Archimedes principle. Simple, no? Okay, so next week we are going to talk about aircraft, and we'll talk about a bit of Bernoulli's principle, and we'll be done with this chapter. Okay, I would say this is the hardest chapter for Form 5. Okay, if you can handle this chapter, the rest of the chapters no problem, so simple. That's why SPM is a must for you to score A. Okay, this is like 3 marks for you. Okay, anyway, let's look at number 6, hydraulic system. So can you see this is 0.5, this is A1. Okay, this is large, this is A2. Okay, so no F1 given, this is F2. Okay, make sure you label your numbers first. Okay, that's what I like to do. Okay, if pressure at point P is 20, oh, they already give you the pressure. So which means, what's the pressure at Q? You don't even need to calculate this, 20 lah. Okay, because like I said, throughout hydraulic system, pressure is the same throughout the whole system. Okay, calculate force required to lift this 4,000. Okay, so F1 A1 equals to F2 A2. F1 I don't know, F1 is what I want. A1 is 0.5, F2 is 4,000, this is 10. So my F1 I should get 200. Okay, which means I use a 20 kilo force to lift a 400 kilo force. 20 times. How good is this thing? Okay, if the area of the small piston is reduced by half, what is the new force required to lift the 4,000? So now I make my 0.5 to become 0.25. I halve it. Okay, so you can calculate again. Okay, divide by 10. So what do I get? I get 100 Newton. Okay, so now I'm using even less force. Because the area got smaller. The smaller the area, the less force we need. Okay, like I said just now. Okay, name the principle. Okay, Pascal principle. Okay, write yourself. State the principle. Okay, what the principle says. Okay, so pressure is the same in a hydraulic system. Okay, explain why water is not suitable for. Okay, here's the thing. Liquid can be used. Any liquid can be used in the hydraulic system, but why don't we use water? Okay, because water has low boiling point. Okay, here's the thing. Your brake uses hydraulic. Why don't we use water in brake system? Brake, you use brake oil. You use brake fluid. You ask your dad, he will know. Okay, in your car, there's a brake cylinder that you open. You need to check your brake fluid. If the fluid is low, you're gonna have a bad time. Okay, I've tried this before. low fluid, I almost crashed my car because I couldn't stop the car because there was no hydraulic pressure. Okay, so why do we use water? Water has low boiling point. In a hydraulic system, it gets very hot. Okay, because you are pressing a lot of force, some of the force is changed into heat. So when you have heat, water will boil. So when water boils, you have air inside the system. Like I said just now, liquid cannot be compressed, but air can be compressed. So when you step onto the brake pedal, you are pressing on the air, you're not pressing on the brake. Good luck, you're gonna crash into the wall. Okay, so what is the property of liquid used in the device? Okay, you can say hydraulic fluid, okay, hydraulic oil or fluid. Okay, suggest a change to Q such as small force act on P will increase the load can be lifted by Q. So I can only change Q here. Okay, so what can you do? You can increase the surface area. Okay, state 3 device uses the principle, but what uses this? Okay, your hydraulic jack. Okay, what else? Your hydraulic brake. Okay, what else uses this, or what else uses hydraulic? Hydraulic lifts. Okay, the one that you use to lift the car. Okay, you have two things to use to lift the car. One is the jack. Okay, one is the lift. They have two forks and then they lift the car up. Okay, so that's hydraulic lift. Okay, oh, our Archimedes. So this is 10 Newton. Okay, when it pushes out 4 Newton of water. So what's the upthrust? Okay, the upthrust is, oh, this is, you see, this is half submerged. Okay, so the water displaced is found to be 4, okay, when I submerge half. So when I submerge full, I should get 8. Okay, so when I push back 8, this should be 2 Newton. Okay, 10 minus 8 ma. Okay, so what principle is being tested above? Okay, Archimedes principle. Explain the principle. What Archimedes say? Okay, upthrust is equal to weight of liquid displaced. Okay, this means I push away how much water will push back how much to me. Okay, what's the upthrust acting on the block? Okay, 4 Newton. What is the tension on the spring? Okay, so 10 minus 4, I should get 6. Okay, I'm sure they're asking about this one. Okay, the block is lower until it's completely immersed. Okay, so before that, it's asking about the half one. Then the string is cut. What is the upthrust acting on the block before the string is cut? I think it's 8. What happens to the block when the string is cut? Okay, it sinks. Okay, because 10 is still larger than 8. Okay, the block is 10 Newton down, 8 Newton up. It will slow down, but it will still sink. Okay, if oil is used instead of water, what will be the answer for B? Oil. This is a trick question. Okay, so oil has lower density. Okay, that's why oil floats on water. So lower density means lower force. Okay, so what will be the answer for B? It will be more than 8. Wait, sorry, it should be less than 4. Okay, so less than 4. Why? Because density, how should I explain this? It is less, oil is less dense. So when you push away the same volume of oil, it's not as heavy. Oil is not as heavy as water. If this makes sense, because oil floats on water, ma. Okay, because less weight of oil displaced. This is a difficult question, okay, because it's very tricky to explain. Okay, so in SPM they won't ask like this, okay, but it's good to know. Okay, this is a brain twisting question. Okay, I hope you understand, because okay, if I push away 5 ml of oil and I push away 5 ml of water, 5 ml of water is gonna weigh more. Okay, a bucket of water weighs more than a bucket of oil because oil is lighter. Okay, so now I'm talking about how much volume I pushed away. So I pushed away 4 Newton here. I'm not going to push that much of oil away, okay, because oil is lighter. Okay, I hope this makes sense. Okay, how is it that ship that made of iron can float water? Yes, that's what I said. Okay, why? Because a ship's weight is equal, to its up thrust. Okay, so like I said, the lift, you're 70 kilo down, the lift is pulling you 70 kg, you are going to stay there. Okay, so you can say the net force is 0, ship floats. What does it mean by net force? 70 up, 70 down, net is 0. Okay, so 0. So what is the part X? X is called ballast tank. Okay, name the upward force X on the submarine. Okay, we call it up thrust, or you can say buoyant force, same thing. Submarine is a streamlined body. What's the advantage of this shape? Okay, reduces friction of water. How does the submarine sink deeper into the sea? Okay, pumps water into ballast tank. Okay, so how does it rise? It pumps water out of ballast tank. Simple. Okay, so simple. Okay, I'm going to talk about the aircraft next week. Okay, so there you go. That's it for this week's lesson. I hope you learned something today. I hope this video is useful. Alright, so I will see you again next week. Thank you for listening. Thank you for paying attention. I will see you again next week. Stay safe and bye-bye.